All right, we are going to look at our next new justification that we're learning today, and that's going to be the angle addition postulate. When I'm writing my proofs, I'm going to start off with my first statement, which is everything from the given. And yes, you need to copy it all down. So it says point D is on the interior of angle MAT, and it's provided that the measure of angle MAD is 41 minus 3x, that the measure of angle MAT equals 19x, and the measure of angle DAT is equal to 16x plus 1. So that's everything in my first statement, so I'm going to justify that with given. And just like with the segment addition postulate question, I'm going to draw a picture to make sure I understand where everything goes. There's lots of X's and numbers and angle information here. So I have my angle. So I have M, A, and T, and then point D is somewhere in the interior. So we're going to put them right here. And it tells us that MAT, the entire angle, is 19x. And that MAD, this section here, is 41 minus 3x, and DAT is 16x plus 1. So now I need to take into account part plus part equals whole. Part plus part equals whole. This is true for angles as well. And I'm going to use the angle addition postulate. When we do the angle addition postulate, my parts are the two smaller angles. And when I'm adding them, I'm talking about adding their measures. So I'm going to include the measure of angle in front. So the measure of angle MAD plus the measure of angle DAT, those two smaller angles, equals the measure of angle MAT, the original large angle. And our justification is angle addition postulate. And again, you can shorten that with POST. I can't write postulate. There we go. Just like our previous example with segment addition, I'm now going to take all of this provided information and plug it into my angle addition equation. So MAD was 41 minus 3x. The measure of angle DAT was 16x plus 1. And the measure of angle MAT was 19x. So I have just substituted So I'm going to use substitution property to substitute all of that information in. Now we are back to an algebraic proof. And so I'm going to combine my like terms first. And my equation is going to say 42 plus 13x equals 19x. And that is simplify. Combining your like terms on one side of the equation means to simplify. And now I'm going to move that 13x on to the other side by subtraction. So by subtraction property, I have 42 equals 6x. I now need to get that x by itself, so I'm going to divide and get 7 equals x, which is division property. And then looking back at my given proof statement, it tells me that the x is going to be on the left, so I needed one more statement that says x equals 7. And again, the way we switch sides is symmetric property. Symmetric property. So that is using the angle addition postulate to introduce the information about angles into our proof and then turn it more like a algebraic proof at the end.